Hello everyone, welcome back to the course Digital Signal Processing. In the earlier classes, we studied about what you mean by digital signal processing and what is the difference between Fourier series and Fourier transformation and where are the applications we can find this digital signal processing we studied. In the today's topic, let us try to look into what exactly the model number 1 is consisting about. In the model number 1, we are going to see one more important transformation as we discussed in the earlier class. We call it as a discrete Fourier transformation. So first we are going to derive an expression for discrete Fourier transformation for the non-periodic signal, and once we have a derivation for the discrete Fourier transformation, we are going to solve some of the problems which is associated with the discrete Fourier transformation. And after that, we are going to see some of the properties of this discrete Fourier transformation. For example, we will be learning about periodicity, linearity property, symmetric property, and multiplication of two DFTs, linear convolution and circular convolution. So all those details you are going to study it in this model number 1. Now let us look into the what do you mean by actually a digital signal processing. Basically, digital signal processing, as the name suggests, we need to have three important aspects in this digital signal processing. So what are those? It consisting of digital, signal, and processing. Basically, signal is nothing but any physical quantity which varies with time, space, or other independent variables. We call it as a signal. Any source of useful information or person event interested, it is also called as a signal. So these signals, it has to be carried from one place to another place. So therefore, it is necessary for us to process the given signal, or it has to recollect, or it has to get back some of the useful information in the given particular event. Then that has to be transmitted from source to destination. So therefore, signal plays an important role. So this is the raw data which has to be transmitted from source and to transmitter. The next one is, when we want to transmit this given signal, how best we are going to transmit it from the transmitter end to receiver end. That plays an important role. So here the digital board will play an important part, because when we want to transmit the data from the one end of the geographical location to the other end of the geographical location, we need to pay an amount for the bandwidth utilization. So how best we are going to utilize the bandwidth, based upon that the cost of transmission of the data from source to destination will matters. And moreover, because of the advancement in the VLSI technology, there are several processing techniques which has healed us, so that we can use our digital gadgets as efficient as possible, and we can transmit the data in a quicker manner. So therefore it is necessary for us to know so how we can process the given signal in a digital manner. The next one is, so how you're going to do that? Yes, we're going to do it in a digital manner, but what are the techniques we need to use? So that we call it as a processing. So depending upon the type of the data what we are going to transmit over the network, based upon that we need to do the processing of the signal. So let's say if you want to transmit a speech process, if you want to transmit a speech signal means, then what is the constitutions of this speech signal and how we need to represent this signal, and is there any possible for us to reduce the some of the bits which we are going to transmit from source end to transmitter end without affecting the actual quality of the signal. That has to be studied, and all those details we will be studying in this processing. Okay. So generally this signals, when we talk about a signal, we can have a broad category of the signal based upon how we are going to classify. But generally we are going to classify the signals into two fundamental categories. One we call it as a continuous signal, and one we call it as a discrete time. So continuous time is nothing but phenomena which continuously varying with the time, it is called as a continuous. And whereas the same event, if we note it down in terms of some discrete interval of time, then it is called as a discrete time. And again, this discrete time, since we are mainly interested on digital signal processing, so we need to go for the analysis of the discrete time signal. And this discrete time signal, again, it has been divided into two categories. One we call it as a continuous value, and one more we call it as a discrete value. So continuous value, as I said, it is continuous with respect to an independent variable. Since we need to process the given signal in the form of binary value, that is either 0 or 1, so therefore it is necessary for us to have an emphasis on discrete event. So therefore we go for a digital value, so that is nothing but a discrete value signal. However, we have already processed the analog signal, that is we already studied about a PCS, that is a principles of communication system. So there, how we can transmit the signal from one end of the source to another end of the destination, and what are the modulation techniques we have used in order to transmit the digital signal over a longer distance. All those details we have studied, but in this module or in this subject we are mainly focusing on how best I can process the given signal in a digital manner, so that I can effectively transmit the data from source to destination with a minimal cost. Okay. So when you talk about a continuous signal and a discrete time signal, so you can see here the continuous signals are signals which are independent of the variables with respect to time. So generally we will be considering a universal independent variable as a time. So this time is independent, and with respect to this time we are going to make a note of some of the phenomena, and these phenomena, it may be which is related to electrical signals, or it may be which is related to the monitoring of some external entities, or it may be which is related to monitoring of some event. So we are going to represent these in terms of a mathematical representation. So in the mathematical representation, there is, if it is a two-dimensional image, if it is a two-dimensional information means, then we are going to represent the independent variable in the x-axis, and the dependent variable we are going to represent in the form of y-axis. And the representation, depending upon the representation, if it is a continuous time means the time will be, it will take a infinite number of values, and if it is a discrete time means it will take a finite number of values. So based upon that, we can have a differentiation between a continuous time signal and a discrete time signal. So you can see here, this is an example how we can have a continuous time signal and a discrete time signal. So we have plotted a variation of the voltage waveform with respect to time over here. So you can see the time in milliseconds we have taken from 0 to 10 milliseconds, and the variation of this we have plotted across the output voltage, that is nothing but V of t. Similarly, the same value we can make a note of this in terms of discrete value. So you can see the time millisecond has been divided into a sampling time, and this sampling time we call it as a TS. So you can see here the k value will be holding the integral value, that is it will hold a value from 0 to 10. So based upon the integration value, we can able to have a discrete values of the voltage, what we are going to plot it over the signal. So this is how we are going to do the sampling method. So next, this is also one of the example you can see here, a discrete signal we have. So this discrete signal we are going to do the conversion of analog signal into discrete signal. We are going to do it how? By using three important phenomena as we discussed in the earlier class. So first, the thing is we are going to do the sampling process, and then we go for the quantization. After quantization, we go for the encoding mechanism. So with the use of three mechanisms, that is sampling, quantization and coding, it is possible for us to convert the continuous time signal into discrete time signal. Okay, and depending upon the phenomena, or depending upon the characteristics of the signal, where we can classify the signals into two categories also, one more categories also. So what are those categories? We call it as a deterministic signal and a random signal. So at every instant of time, it is possible for you to make a note of an values of the any particular signal means, then such a signals we call it as a deterministic signal. Whereas random signal means, if any event, if you want to make a note of this, if it is value, if it is not possible for you to identify means, then such a phenomena or such a event we call it as a random signal. And we cannot have a characteristics, we cannot define a characteristics for the random signal, whereas we can determine or we can represent the characteristics of the given signal if it is a deterministic signal. For example, you can see here we have a two deterministic signal, that is S1 of t is nothing but AT. So depending upon the time variable, this S1 of t, if A is a constant value means, then depending upon the time t, it will be varying. Whereas this S2 of t, you can see it is depending upon two important parameters, that is a variable x and y. And if I substitute x and value y, definitely I will be getting depending upon the constant variable a and b. But whereas you can see here a random signal, it is varying with respect to time. There is no any characteristics we can frame, or it is not possible for us to identify an exact value at a particular instant of time. So such a signal we are going to call it as a random signal. So this random signal plays an important role when we want to analyze the channel characteristics. In the channel characteristics, it is not possible for us to identify the deterministic signal. So therefore, we go for the random signal processing. So there, this random signal processing plays an important role. So basically, in the signal processing system, so what are the important tasks we need to consider? It depends upon the type of the applications we are going to use. So in terms of communication, we go for the modulation or the demodulation. And if it has to be transmitted a digital signal means, then we go for the multiplexing and demultiplexing. And if the data has to be transmitted with a minimum number of bits means, then we go for the data compression. Similarly, the signal processing may be applied to the speech system, that is identification of the speech and transformation of speech to text or text to speech transformation, we can do it. And with the use of this signal processing, it is possible for us to provide a security by using some encryption decryption mechanism. And also this digital signal processing, it plays an important role in filtering mechanism. For example, in the earlier classes, we studied about one original image we have taken, and for that original image, if I apply a low pass filter, how the image will look like, and how the Fourier transformation value, which will be centered around the region, and if I apply the same image through a high pass filter, how the Fourier transformations coefficients will be centered around the regions. All those details we studied in the last class. And we can go for the enhancement with the use of this digital signal processing, especially in the medical field, where the image that is only the raw data which has to be processed and it has to be analyzed for the doctors. So the enhancement of the image will clearly depicts what exactly the characteristics of the image it is there. So therefore, this signal processing can be applied for the enhancement. And the next one is, finally, we can make use of this signal processing in the data manipulation. That is, in case of watermarking and some processing of the given signal, or in multimedia applications, we can go for this signal processing techniques. Okay, so now let us try to understand. So what are the advantages then? Why we go for this digital signal processing is because it is more accurate and it is independent of the time. So because of the two important factors only, we go for this digital signal processing. And also this digital signal processing, it is as efficient as possible. And even if you do the calculation as for today, and if you represent the same calculation after 10 years, it will be written. But whereas if you go for the analog communication, that is not the case. So therefore, because, and also the cost of implementation of any application through the use of this digital signal processing, it is very minimum when you compare to the analog signal. So therefore, these are some of the important advantages which has been listed for digital signal processing. It is more flexible. Yes, of course, it is not complex. That is why it is more flexible, and it is easily storable. That is, since in the digital data processing, whatever the information we want to represent, it will be represented in the form of zeros and ones. So therefore, it is easy for us to store the data. And we can have as I said you, the accuracy of the system is more in the digital signal processing, and it can be easily reproducible. As I said, it is a cost effective. But there are some disadvantages there. And what are those disadvantages is that we need to use several analog to digital converters and digital to analog converters, and we need to use signal processors. Okay, because of this, we can say that this will be an additional cost for the processing of the signal. So that might be the one of the limitation. And one more important disadvantage of this digital signal processing is that the rounding of the errors, because generally in digital signal processing we will be working on the discrete values. So if you have an rounding of the information, either it has to go to the positive, it has to go to the next higher level, or the next below level. So based upon that, the precision what you are going to set, based upon that, the accuracy will be reduces. That is the finite word length. That is one of the limitations what we are going to see it in the digital signal processing. Okay, so this is the overview of what we are going to study in this digital signal processing. So in the next class, we will go into the deeper insights of the model number 1. Thank you.